Hello, students. Today we will discuss about the topic that is circuit breaker. So, what is a circuit breaker? Circuit breaker is basically a mechanical switching device that can make or break a circuit either manually or automatically under normal and abnormal conditions. So, the circuit breaker is basically it is a switching device which can make a circuit or break a circuit under abnormal condition either manually or automatically. So under normal conditions also means during the servicing period. So what are the characteristics of a circuit breaker? So it can make or break a circuit under normal operating conditions either manually or by using the remote control. Under abnormal or fault conditions, it can break the circuit automatically. It can isolate the circuit under fault conditions. So what happens if you are unable to isolate? So the remaining part of the power system will be damaged. So it will isolate the circuit. So these characteristics of the circuit breaker make it best for switching and protection of the power system. So next thing is the principle. The main duty of a circuit breaker is to switch on and switch off the circuit in normal and abnormal conditions repeatedly. The operating principle of a circuit breaker is very simple. A typical circuit breaker will have fixed and moving contacts which are called as the electrodes. So these contacts will be closed under normal conditions. So if the fault occurs or surge occurs, the contact will open automatically or manually. Under fault condition, the trip coil gets energized, resulting in the movement of the contacts. So it will move the contact away and resulting in the opening of the circuit or breaking of the circuit. So the main problem occurring after the circuit breaker, after the opening is arc phenomena. Arc phenomena occurs during opening of the contacts. So this is the disadvantage here, and we have to extinguish this arc as early as possible. During separation of contacts, an arc is struck between them. Until the arc discharges, the current in the circuit continues to flow. Arc delays circuit interruption, produces significant heat, and which can damage the circuit breaker and the system also. Hence, the arc should be extinguished as early as possible. So, during fault or short circuit, the large amount of current. So, the fault itself means, or short circuit itself means, more amount of current flows in the circuit when compared to the normal condition. So before the action takes place, before the protective mechanism opens, that means before the contacts open. So since the current is large, even if we separate also, the current density increases due to this huge amount of current or short circuited current or fault current. So this leads to rise in temperature, and the heat produced is sufficient to ionize the medium, either it may be air medium or oil medium. The ionized medium acts as a conductor and an arc is struck. So this ionized medium provides the low resistance path for the current to pass. So for this, we have to extinguish the arc. So before understanding the methods to extinguish the arc, let us try to analyze the factors responsible for the maintaining the arc between the contacts of the circuit breaker. The reason can be confined to 2 points, that is potential difference between the contacts and the ionization and the ionizing medium. The potential difference between the contacts is sufficient for the arc. So potential difference is sufficient because during that time it is the time of the fault or short circuit or the short circuit current or the heavy current is flowing. So that's why the potential difference is sufficient. So it is sufficient for the arc, that potential difference is sufficient for the existing of the arc. Also the ionized medium. The ionized medium will be having the tendency to maintain the arc. Next thing is different methods of arc extinction. So since this arc is making the current to pass and the purpose of the circuit breaker is not disturbing the purpose of the circuit breaker, we have to search for the methods to extinguish the arc as early as possible. Among these, the main two methods are high resistance method and low resistance method. First we will see the high resistance method. In this method we will provide resistance for the arc such that the current will become insignificant to maintain the arc. So we will provide a resistance for the arc, so the current will be insignificant to maintain the arc. So the methods to increase the resistance are increasing the arc length, cooling the arc, reducing the area of cross section of the arc, splitting the arc. So increasing the arc length, cooling the arc, reducing the area of cross section of the arc, splitting the arc. This method, that means this high resistance method, generally we will use in the DC circuit breakers and low capacity AC circuit breakers, because in this process of extinguishing the arc, more amount of heat is produced. So we will use this only in low capacity AC circuit breakers along with the DC circuit breakers. Next thing is low resistance method. Here the resistance of the arc will provide low resistance for the path until the current becomes zero. That's why this is also called as this. That means this low resistance method is also called as zero current method, because we are providing the low resistance till the current gets zero. So if the current gets zero, the arc naturally extinguishes. The low resistance method, so since we are providing the low resistance, the heat will be less. So we will use this type of method in the high power AC circuit breakers. And also this method prevents the restriking of the arc. Another thing is we have to de-ionize the medium as early as possible. So if the medium between the contact is de-ionized as quickly as possible, the possibility of restriking can be reduced significantly. So de-ionization, we can follow different methods. They are increasing the gap between the contacts, increasing the pressure, cooling the arc, gas blast effect. So increasing the gap between the contacts, increasing the pressure, cooling the arc, gas blast effect. So we will be having different types of circuit breakers based on the medium we are using, that is air, oil, sulfur, hexa, fluoride, gas or vacuum. So the different types of circuit breakers based on this medium are air magnetic circuit breakers, air blast circuit breakers, oil circuit breakers, sulfur hexafluoride circuit breaker, and vacuum circuit breaker. And we will see about the air magnetic circuit breaker in the coming class. Thank you for listening.